Today we're going to start with page 6 of our notes from the Chapter 5.8 packet. We're going to talk about solving higher degree polynomials that are not factorable. If you come across a polynomial like this long one, you won't be able to factor it. You don't know any way to factor this polynomial. So what you have to do is you have to solve it graphically, and we can only find the real roots. So what we have to do is we have to make a sketch of the graph, and that's using the graphing calculator. And then we indicate the roots on the graph, and then the roots are going to be where it touches the x-axis. And then we list those real roots, which are the zeros. So what we're going to do is we're going to use our graphing calculator. So if you can get your graphing calculator out right now, you want to press y equals. And y equals, you want to put y1 is equal to the polynomial. If you want to get up to this x to the fourth, this button underneath the clear button is the exponent button. So 2x, and then you raise it to the fourth power. Then you have to right arrow out of the exponent, and then you put the rest of it in like you see here. Here's the polynomial that we put in y1, this long one. So you can see that I've already put this into my calculator before I turned on the camera. And then under y2, you're going to put 0 because we want to calculate the zeros. And there are a couple of ways to do this, but this is the fastest way, is if you put y2 equals 0. And then we're going to press the graph button, upper right. And before we press the graph button, we're going to change the window. So over here on the side, I listed what your window should be. Over on the left, this is the x-axis, so this is x min. So we're going to make our x min equal to -6 on our window. And then over here, this goes over to 5. This counts by twos, but this is actually 5. So we're going to let our x max be equal to +5, just because that's where our x-axis goes from. It goes from -6 to +5. And then I indicated the y min and max so you can see the whole thing. So if you press your window button, change your x min, it should say -10. If you change it to -6 and +5, and then I indicated, the scale on the x-axis we'll put as 1s, and the y min and max should be listed as I showed you what to do. So then when you press the graph button, you'll get this W-shaped graph, and we have to try to sketch this as well as we can. Well, the zeros are where it crosses over the x-axis. So it crosses over here. These are all, the tick marks are by 1, so this is -1, -2, -3, -4, -5, and -6. So it crosses over at x equals -2. So I'm going to put a big point actually on -2, and it actually crosses over here at -4. So I'm going to put another dot on -4. And then it goes through the x-axis. It's kind of hard to tell what's going on here. It goes underneath very slightly. So how you figure out what those values are is you hit the second button, and then you hit the trace button. And then we're going to find the intersection. It's the intersection of y1 and y2. So hit enter. And then my cursor is already over there because I've done this already, but you want to move your cursor close to the point of intersection of the graph with the x-axis. So anywhere in this location is okay. So you hit enter once, twice, 3 times, and it'll tell you that it intersects the x-axis at x equals 2. Right there it tells you. So you're going to put a point on x equals 2. And then there's another one over to the right just a little bit. So we're going to go through the same process again. Second, calc, intersect, option 5. And then we're going to go over to this side of the x-axis and hit enter 1, 2, 3 times. And so this intersection is at 2.5. So over here at 2.5, I'm going to put another x-intercept. And this graph goes down underneath the x-axis just a tiny bit. And where does it go through the y-axis? What's this value right here on the y-axis? Well, all you have to do is look at the table. So second table, and here's another way to look to see where the zeros are. All those y2s are zeros because that's what we put in. But the y1, remember at -4 it touched the y-axis. At -2 it touched the y-axis. And down here at positive 2 it touched the y-axis. And you can't see 2.5 because these x values are going up by 1s. So that's another way to see that. But what I wanted to do is see when x equals 0, what does y equal? When x equals 0, y is equal to 80, so that's the y-intercept. So I'll put up here, I'll put an 80 because it's a good idea to mark your y-axis for what it is, the value. So let's just try to draw as best we can. I'm not a very good artist, but I'll try. So we come way down here. We come up through y equals 80, and then we come down and we hook around a little bit, and then we come up and we put an arrow at both ends because this goes up forever in both directions. So what are the zeros? The zeros are, like we said, -4, -2, +2, and +2.5. That's it for that one. Now let's see if we can find these roots graphically. If you want to shut off the video for a moment and try this on your own with your graphing calculator and then turn it on and see what, if yours matches mine, that's a great idea. That's what good students might do. So this is 8x to the 4th, and then it's minus, and I'm going to insert a 12, x to the 3rd minus 22x squared plus 3x plus 5. So hopefully I got that in right. Now this x-min is going to change. This x-min is now -3. Look at that. That x-max is now 4. And I'm telling you to go down to -40 and up to 20 on your y's because I did this before and I knew how high it had to go. So let's just change this to -3 to 4. And then we'll change our window. -3 to 4. And what I tell you, -40 to 20. And then we'll just press the graph button and see what that one looks like. That goes way down here. So we have 4 points of intersection. So we're going to go through the process 4 times to see what these values are. It's kind of hard to tell because they're halfway between the tick marks, some of them are. So we're going to do second calc, intersect. Pull our cursor over to that one close by and hit enter 3 times. And -1 is where it goes through the first time. So we'll mark our -1. Second calc, option 5, intersect. Enter, enter, enter. Oh, -1/2. And that just goes to the x-axis a little bit, so I'll just kind of go like this. And then, second calc, intersect again. We'll go over to this side, hit enter 3 times. Oh, positive 0.5 right here. And then second calc, intersect again. And then I'm going to hop up to the x-axis by pressing my up arrow. It just takes less time to move that cursor straight across and go all the way down and all the way back up again. So this is my speedy way to get there. And then enter, enter, enter. Oh, 2.5 is where they intersect. So 2.5 is here. Now I'm going to look at where the y-intercept is. So I'm going to look at the table, and it looks like it goes through 0, 5. So up here at 5. And then I'm going to try to match that graph. It goes way down, doesn't it? Go through this x-intercept. Goes way down, and then it comes way back up again and goes up forever. So the 4 points of intersection are, what we say, -1, -0.5, +0.5, and +2.5. So those are the 4 zeros on that one. Going over to the next page, we're going to try to do these roots. So try this one on your own if you want to shut it off and turn it back on again. This is an x to the 5th. So this is going to be another term in here. So let's 3x to the 5th power is the first one. And then we're going to get to plus 2x to the 4th power minus 35x to the 3rd power minus 18x squared. Oh, I got to insert an x squared. And then plus 72x. Hopefully that's all right. And what does this window say? This window says x min is -5, x max is 4. Oh, this goes down to -100. Wow. It's a long ways down. -5 to +4, down to -100, and up to 50. All right, let's see what this guy looks like. 1, 2, 3, 4, 5. Wow, there's 5 times it hits. Must be because it's an x to the 5th. It touches it 5 times. Second, calc, intersect. I'm going to hop up to that x-axis with my up arrow so I can speed across here. Enter, enter, enter. -3. Second, calc, intersect. Hop down to that x-axis and speed across. Enter, enter, enter. Oh no. Enter. Oh, better do it again. Went too fast. Second, calc, intersect. Enter, enter, enter. -2. Probably could have gotten that right off from the table of values. Oh, let's do that. Let's see what the table says. Oh, -3, -2. Oh, 0, 0. There's 1. Don't have to go through the other stuff. 3, 0. Is the table going to tell us anything else? Nope. All right, that gives us 4 at least from the table of values. And let's see, what else don't we have? We have -3, -2, 0. Oh, we have somewhere between 1 and 2. Second, calc, intersect. Speed across. Enter, enter, enter. Oh, 1.33333333. That's 1 1/3. That's 4/3. If I second quit out of there, if I press the X button, it'll tell me what X is equal to from my previous command. So that's what our X value is from the home command. I'm going to do a math frac. Oh, that's 4/3, which is right there. Okay, let's take a look at this graph again. So now it starts from the below. It goes up and comes back through and goes down, comes up, goes down, goes way down, comes back up, and it goes up and it goes down. So there's your beautiful graph, and the zeros are -3, -2, 0, 4/3, which is 1.3 repeating, and 3. And let's see. We're now going to construct our own graph from the given roots. Before, we had to figure out the roots. Now we're going to be given what the roots are, and then we're going to be writing an equation from the roots that we're given. So if we're given roots p and q, like if we're given the roots -3 and -2 or 0, what we can do is we can write an equation with the roots p and q by just doing x minus the first root, x minus the second root, multiply them together. For example, if we are told this is given, the roots are 4 and 2. 4 and 2, so that means we can go over to 4 and back to 2, and those are the two roots. There's only 2. What is an equation? Well, as an equation is y equals, make sure you write it as an equation, and now we can say x minus the first root times x minus the second root. And you can leave it like that if you want, because that's an equation, so that would be okay. Or since we love to FOIL, we can FOIL this out. X squared minus 2x minus 4x plus 8, which is, and that's okay to leave, but not really, x squared minus 6x plus 8. So that's a parabola, and it has a y-intercept of 8, because if we plug in x equals 0, y equals 8, you can check that on your calculator if you want. But 1, 2, 3, 4, 5, 6, 7, 8. It goes up there. And if you want to put it in your calculator, you can. You can put it in like this if you want. X minus 4 times x minus 2. Or if you want to put it in x squared minus 6x plus 8, you can do that too. It'll give you the same thing. I'm going to press my zoom key. Zoom standard. That gives me a standard window. That's the 10 by 10. So that's what our graph looks like. It goes through 2 and 4, just down a little bit. If we want to look at the table of values, let's look at the table of values, and let's be a little accurate, I guess, on this. So it goes through 1, 3. Let me pull this up a little bit. 0, 8, 1, 3, over 1, up 1, 2, 3. And then it goes through 3, negative 1, 3, negative 1, and then 5, 3, and 6, 8. So over 5, up 3, over 6, up 8, a very symmetrical, beautiful parabola. Isn't that nice? So there we go. We got an equation. We sketched its graph. Go over here. Oh, now we have 3 roots. Negative 5, negative 2, and 1. Well, let's put them on the graph. Negative 5. Boom. Negative 2. Boom. Positive 1. Boom. What is an equation? Well, an equation is y equals, and now we're going to do x minus negative 5. X minus negative 5 is x plus 5. X minus negative 2, which is x plus 2. X minus 1. Do you have to multiply those all out? No, don't bother. It's too much work. Okay, let's just leave it like that. That's fine. So what do we have? I'm going to get this guy out of here, this y2. So we got x plus 5, and we've got x plus 2, and then we got x minus 1. Graph. See where he goes. Oh, it looks like the letter N. Up, down, up. So if we want to look at the table of values, find a few points that we can put on our graph. 0, negative 10 goes down here. 228, oh, that's off our graph. Negative 3, 8 goes up here. Negative 1, negative 8, oh, we can put that on. Negative 4, 10. Negative 4, 10 goes up here. And anything else interesting? Negative 5, 0, we knew that. Oh, negative 6, negative 28, too far. So we can just connect those points with the letter N. Let's do that. Down and up. There's our letter N. It's beautiful, huh? Kind of looks like the same. All right. Oh, look at this. We have roots that are positive and negative 3. Okay, here's a negative 3. Here's a positive 3. What's an equation? Y equals x minus 3, x plus 3, right? Those roots are negative and positive 3. We can leave it like that if we want. Or, if we love to FOIL, we know that's DOTPS, which is x squared minus 9. Take a look at that. I guess it would be faster just to do x squared minus 9 rather than put it in parentheses. So let's take a look at that graph. Oh, there it goes. Let's take a look at the table of values. What do we have? We have negative 4, 7, negative 4, 7, negative 3, 0, we knew that. Negative 2, negative 5, negative 1, negative 8, 0, negative 9. What else we got here? 1, negative 8. 2, negative 5. 3, 0, we knew that. And 4, 7. should be across from here. All right, so now we can just draw our beautiful parabola. Coming up. And there you go. There's a beautiful parabola. How about that? All right, next one. The roots are negative 3, 2, and 0. Y equals x plus 3, x minus 2, and x minus 0. Oh, x minus 0 is just x, isn't it? So we can do x plus 3 times x minus 2 times x. And if you want to knock yourself out, you can FOIL those and multiply them all by x, but it's really not necessary. I don't think that would save us any time. Let's put these roots on our graph. Negative 3, positive 2, and 0. Let's put that in our graphing calculator, see what it looks like. X plus 3 times x minus 2 times x. Another letter n. Let's look at the table of values. Negative 1, 6. 1, negative 4. 3, 18. That goes off our graph. Negative 2, 8. 3, 0. We knew that. And oh, negative 4, negative 24. That goes off our graph too. All right. Let's see if we can sketch this. Up, down, up. How's that? Kind of looks the same. Next. Oh, I don't think we need to do this next page. This will be tomorrow. Have a good night.